Hi, I am Madan, Assistant Professor, Department of Mechanical Engineering in PSN College of Engineering and Technology, Autonomous. He lectures the kinematics of machines. Mechanics, first of all, mechanics means science dealing with motions. The division of mechanics, there are two. One is statics, another one is dynamics. Statics means that deals with system which are not changing with time. And dynamics is deals with system which are changing with time. Next, there are two types of dynamics. One is kinematics, another one is kinetics. Kinematics is deals with motions and time, and kinematics is deals with motions, time, and force. So, because the kinematics will not consider the force, then statics is a structure, kinematics is a mechanism, and kinetics is a machines. Next, structure. A single body with no motion, the combination of bodies with no relative motions. Then mechanism. Mechanism means the device. This means the device to transfer is given input motion to specified output motion. Then last one is the machines. Machines is a device to transfer energy to do useful work. So there are the statics and it is a statics and kinematics and kinetics. Then the main difference between the machines and a structure. First of all, machines means a parts of machine move related to one another, whereas the member of structure do not move relative to one another. Then second, the machine transfer the available energy into some useful work, but the structure no energy is transferred into useful work. And the link of your machines may transmit both power and motion, but the structure transmit force only. Next we discuss kinematic pair. This a pair means it's a two combination element. Okay. The two link or element of a machine in contact with each other are said to be form a pair. If the relative motion between them is completely constrained, it is called as pair. As another name is a kinematic pair. The next, the relative motions between the element. There are five types of pair. One is sliding pair, another is standing pair, rolling pair, screw pair. Last one is a spherical pair. First we have explained sliding pair. When the two elements of a pair are connected in such a way that one can only sliding relative to the other, it is called as sliding pair. Next is standing pair. When the two elements of a pair are connected in such a way that one can only turn. So note that is a turn. So about the fixed axis of another link, it is called as standing pair. Another rolling pair. The rolling pair is the two elements of a pair are connected in such a way that can one roll over another fixed link. It is called as rolling pair. This example called a roller bearing. Next, screw pair. So that when the two elements same, when two elements of the pair are connected in such a way that one element can turn about the another by screw threads. By screw thread. This known as is a screw pair. For example, bolt, nut, then lead screw of the lathe with nut. Last one is a spherical pair. When the two elements of the pair are connected in such a way that one element turn about the another fixed element, this is called as the spherical pair. For example, ball and jacket joint. And attachment of the car mirror is a good example for car mirror for the spherical pair. Next topic is according to the type of contact between the element. So there are two pairs. One is a lower pair, another one is a higher pair. First is made lower pair. The lower pair, when two elements of the pair have a surface contact, note this. The lower pair means a surface contact when relative motion takes place. It is known as a lower pair. For example, we see that sliding pair, tanning pair, and screw pair from lower pair is it is an example. Then higher pair. The higher pair is a line contact. That's all. The lower pair means is a surface contact, and higher pair is a line or point contact with relative motion to take place. It is called as tanning higher pair. So, for example, a pair of friction disc, truth theory, belt and rope drives, ball and roller bearing, and cam and followers is a good example for higher pair. So the main meaning of lower pair is example tanning pair and screw pair. Higher pair is example for bearing, cam and follower, ball and roller bearing, rope drivers, that's all. And the next is according to the type of closure. One is a self closure, second one is a force closed pair. When the two elements of the pair are connected together mechanically in such a way that only a clear kind of relative motions occurs, it is called as a self-closed pair. It is as a lower pair. It's a good example for self-closed pair. Next one is a force-closed pair. So, when the two elements of the pair are not connected mechanically, but are kept in such a way that action of external force, this pair is called as force-closed pair. It is a cam and follow is an example for closed pair parallel. Good example. This sum of diagram is there for lower pair and the higher pair example diagram. We can see. It is a surface contact of the lower pair to contact with the surface contact. It is a chain drives and is a belt rope. It is a higher pair example. It is a line contact. It is a gear. It is a one type of pair. It is a higher pair. It is a point contact. Next topic is a kinematic chain. Kinematic chain. So already I told what is mean kinematics. Kinematics considers with the motion and the time. Okay, it's not considered for the force. The kinematic is not considered for the force. So when the kinematic pair are coupled in such a way that last link is joined to the first link to transmit defined motion is called as a kinematic chain. So first link, the last link to connect to the first link. Okay, to do transmit defined motion is called as kinematic chain. So some formula is there for chain. I is equal to B minus 4. Here, B means is a kinematic chain and L means number of link. P means kinematic, the form of kinematic chain, and L means the number of link. Here, so another one is the relative motion. Another formula is J is equal 3 by 2 L minus 2. It is a main use of the higher pair. It is the same as L means number of link, and J means number of joint. J means number of joint. So for the conditions, the above two equations applicable only to kinematic chain. In such a way, lower pair are used for first formula. This formula I is equal to B minus 4 means it's a lower pair. We are when you use for the lower pair, we can use I is equal to B minus 4. When you apply for the higher pair, we can use J is equal 3 by 2 L minus 2 formula. For example, next one is a type of joint. Uh, there are different type of joint is there. First one is binary joint. So binary joint means when the two links are connected in such at the same connection. When the two links are joined at the same connection, this joint is known as binary joint. For example, this is a 4-bar link. 4-bar link. Link number 1, number 2, number 3, number 4 is a link. 4 link, and A, B, C, D means it's a joint. A, B, C means it's a joint. It is a kinematic 4-bar link mechanism. Here, one formula is there, I plus H by 2 is equal 3 by 2 L minus 2. Here, J means is a joint, H means is a higher pair. H means is a higher pair, L means the number of link. Okay, then here, I means is the number of binary joint. So there are 4 links there, 4 joint. Here in this diagram, so number of link is 4. The number of link is 4. The number of joint is 4. So here J is equal 4 and L is equal 4. And but I is equal 0 because it's a higher pair is not there. Higher pair is not there. Higher pair only for line contact or point contact. So here line contact and pair contact is not there. So we put the H is equal 0. H is equal 0. So this value is apply for this equation. So I 4. Okay. Here you got it. 4. The chain number of the apply of the equation for chain is 4. Next is a ternary joint. So the ternary joint is a 3 link. Okay. Binary joint means 2 link, and the ternary joint is 3 link. The main difference. When 3 links are connected or joined at the same connection, the joint is known as ternary joint. So here the example. Here kinematic chain having binary and the ternary joint. It's a combination of binary and ternary joint is there. Here number of link is 6 is there. Number 1, 2, 3, 4, 5, 6. So number of link L is equal 6 is there. Here number of joint. Here number of joint means A, B, C, D, E. Then the binary joint means E and C. Another column is E dash or C dash is okay. Because E and C is a ternary joint. We connect the 3 link. You saw that. So number of link is 6 and number of joint is 7 because A, B, D is a 1 link, 2 link. Okay. And E and C is a ternary joint, that is 2 connecting, 2 joint. So total 7 joint. So we are applying this formula. So L is equal 6, J is equal 7. And the higher pair is not higher pair. So because the line contact and the point contact is not there. So H is equal to 0. So this value apply for the equations. So you got it the 7. The kinematic chain is 7. Next means quaternary joint. Quaternary joint. Here is a 4 link, and binary is a 2 link, ternary is a 3 link, and quaternary joint is 4 link. When 4 links are connected at the same connection, the point is called as quaternary joint. Here. So that here you see the diagram. Number of link, so L. How many number of link is there? Number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 8 links there. And number of joint. So number of joint is A, B, C, D, E, F, G. So here number binary. So here number of link is 11. Number of joint is 15. Number of joint is 15. So A, B. A is a 3 link. Okay, so we consider 2, and B 3 link connected joint. So here is a 2, A. So here is this diagram we have binary joint is there, and ternary joint is there, and the quaternary joint is there. The quaternary joint is G. G is a quaternary joint, and A, B, C, E, and F is a ternary joint, and A, D is a binary joint. So 2 links there, and so we are applying these values to equations. We got it. L is equal 11 and J is equal 15. So okay. Next, one flow chart is there. First one is a link. Link means or element. Second is the kinematic pair or joint. Next, kinematic chain. Next is a mechanism. Last one is the machines. First you can say link, next kinematic pair, next kinematic chain, next mechanism, next machines. Mechanism is a very good topic. Mechanism. When one of the link of a kinematic chain is fixed, the link in the chain is known as mechanism. So you see that kinematic chain already we told. Kinematic chain means the last link connected to the first link to transmit of the power, the energy. Okay. Next, mechanism. Another step is mechanism. When one of the link of a kinematic chain is fixed, the chain is known as mechanism. So, for example, if a 4-bar mechanism is there, one link is arrest, one link will be arrest, one chain is arrest, is called as mechanism. It may be used for the transmit or transmit function. A mechanism with 4 links is known as simple mechanism. Mechanism is a more than 4 link is known as a common mechanism. When a mechanism is required to transmit power or to do some particular type of work, it then becomes a machine. So mechanism, I explained the mechanism. Next, machine. When a mechanism is required to transmit power or to do some particular type of work, any one work is there, any one work is B. So particular type of work, it then becomes a machine. The degree of freedom is a degree of freedom. So it is defined as the number of input parameters. Which must be independently controlled in order to bring the mechanism into a useful engineering purpose. It is possible to determine the number of degree of freedom of the mechanism directly from the number of links. And the number of joint and type of joint which the mechanism includes. So to find out the degree of freedom, you want to the number of link and the number of joint and number of type. You need to find out the degree of freedom. Here is the degree of freedom for us there. So n is equal to 3 L minus 1 minus 2J minus H. This equation here already told, n is the number of degree of freedom. Okay. N means the number of degree of freedom, and L means the link, J means a joint, H means is a higher pair or lower pair. So, if there are no 2 degree of freedom pair is a higher pair. Higher pair is a 0. You put these height is equal to 0. So n is equal to 3, open the bracket, L minus I, close the bracket, minus 2j. In substitute, the number of L is equal to 1. Degree of freedom is 1. Height is equal to 0 means you got it to 3L minus 2j minus 4c. This equation is the Kepler criterions. Next is the inversion of mechanism. Inverse of mechanism. When one of the link is fixed in kinematic chain, it is called as mechanism. So we can obtain as many mechanisms such as number of link in kinematic chain by mixing in tanning with different links in the kinematic chain. This method of obtaining different mechanisms by mixing different link in a kinematic chain is known as the inversion of the mechanism. There are three importance of kinematic chain. That is the three types of or three important type. One is a 4-bar chain. Second is single slider crank chain. Double slider crank chain. First one is 4-bar chain. 4-bar chain means there are 4 links there. 1, 2, 3 is a link. A, B, C, D is a binary join. The simplest and the basic kinematic chain is now 4-bar chain. Sorry. And according to the Kirchhoff laws for the 4-bar mechanisms, the shortest link length plus longest link length is equal to the greater than or equal sum of the remaining 2 link length. If there is to be continuous relative motion between the 2 links. For diagram, for figures, so it is a 4-bar link. Another one is the inversion of 4-bar chain. Inversion of 4-bar chain. It is an example for beam engine, coupling rod of locomotive, and watt indicator mechanism. A good example for inversion of 4-bar chain. And here is a beam engine. Beam engine is one is a rotating motion, another is a reciprocating motion. The cylinder is a reciprocating motion, and the crank is a rotating motion. Crank is a link 1, a link 2. Okay. In the frame means is not movement of frame. It is a no degree of freedom. The frame is a no degree of freedom. So link 1 is a frame, link 2 is a crank, and link 3 is a connecting rod. Okay. And the link 4 is a lever. So there is 4 link. This is an inverse rod. Next is a locomotive. Locomotive is a condition of 4 link. Link 1, 2, 3, 4. So there are and the joint is A, B, C, D is a binary joint. And here the link 2 and link 4 is equal. Length. The link length and L1 and L3 is a length is equal. It is a main difference of locomotive. And a good example for railway wheels is a locomotive mechanism we are used. We are see that train wheels. And what's indicated mechanism? What indicated mechanism is a seamless is a two mechanism. Two is a linear motions. There are 4 links there. Link 1 is a frame, link 2 is a link lever, and link 3 and link 4 is there. Next one is the classification of mechanism. Based on the mobility degree of freedom, that is DOF means degree of freedom of the mechanism. Consider the degree of freedom of output only. There are 2 types. One is a constrained mechanism and unconstrained mechanism. Second is a considering the sum of the degree of freedom of input and output portions. That's a single and is a multiple degree of freedom. Constrained mechanism. So a good example for 4-bar mechanism, slider crank mechanism, and 5-bar mechanism with 2 inputs. A good example for constrained mechanism. The constrained mechanism is one independent output motion. Independent output motion. Output member is constrained to move in a particular manner only. An unconstrained mechanism is a good example of automobile differential train during turning and vehicle on a curve. And the four-bar mechanism with the one input. So unconstrained motion, output motion has more than 1 degree of freedom. It is a main difference for constraint, it is a unconstrained mechanism. Next, single degree of freedom mechanism. Single degree of freedom is example for four-bar mechanism and cam follower mechanism. Single freedom. For example, sum of the input and output degree of freedom is 2. And sum of the input and sum of the output degree of freedom is 2. Single means degree of freedom motions, one depending input motion and one independent. Oh, sorry, the motion one independent input motion and one independent output motion. This is the output and input is same. Here is a single degree of freedom. Here is a four-bar mechanism. Four-bar double rocker inversion, double rocker inversion. So example. Next, multiple degree of freedom. Multiple degree of freedom mechanism. It's a good example for automobile differential 3D cam mechanism. Another one is a 5-bar mechanism. Here, sum of the input and output motion degree of freedom is more than 2. Single means the sum of the input and output motion degree of freedom is 2, but multiple is more than 2. Okay. It is multi-degree of freedom. It is a differential unit. You saw that here. This differential unit. Bubble gear. The bubble gear is a multi-degree of freedom. Next is based on classification mechanism based on the position in space. Occupation mechanism. Planar mechanism, spherical mechanism, last the partial mechanism. Planar mechanism. It's a planar motion. Planar motions. The planar motion, the particle or point of the members move in parallel plane. Parallel. Example, planar 4-bar mechanism, slider crank mechanism, cam follower mechanism, means helical cable. The 4-bar crank rockers are coupled curve. You see that crank rocker curve mechanism. It is a 4-link. Is there? There are 4 links. So frame is one link and R1, R2, R3 is another link. So there are 4 links. Here is a binary, AB is a binary joint and BC means it is a ternary joint. So 4 link and binary joint and ternary joint is there. Here is a stove, engine stove. Here is only one mechanism. Next, spherical mechanism. Spherical mechanism, the point maintain constant distance with respect to a common center point in any position during motion. For example, universal joint, then double gear drives, and then spherical 4-bar mechanism. Here is a spherical mechanism, universal joint. First, you see the diagram. Spherical universal joint. Second is the bubble gear. Last, the added is spherical. That is a spherical mechanism. This is a partial mechanism. The point can occupy any position in space. Partial, for example, partial 4-bar mechanism, warm gear drives. Another last one is serial manipulators. Manipulators here, for example. It is a partial mechanism. Another one is a classification mechanism based on the connection of the output member. Connection of the output member. So there are two types of output members. One is open mechanism, another is a closed mechanism. Here, open mechanism, output mechanism not connected to the fixed link. Example, robot arm of the each earth movers. Here is an open mechanism. Example, pushing is a robot arm. Closed mechanism, output member connected to the frame, Forward mechanism, slider mechanism, cam forward mechanism is example for closed mechanism. Next, common of mechanism. It's a link element, kinetic pad, join and kinetic chain. Next, another one topic is link and element. So already we told link and element. So another, the link is a single resistant body, combination of resistant bodies having relative motion with another resistant body. It's a combination of the resistant bodies. It's a rigid body, is a no movement. This is that flexible and liquid. Here, link is a one node, link with node, two node, three node, and four node. So first one is a node, one node. And A means is that there is no node. And a binary link. So you see the diagram, A is a binary link, B means a ternary joint, ternary link, C means a quaternary link. That is a binary link is a two node, ternary 3, quaternary 4. And already I told joint. Joint means it is a combination of two links kept in permanent contact permanently, particularly kind of relative motions between them. And this topic already we discussed. Okay, students, thank you for my lectures. Thank you.